In this video, we're going to take a photo in Android and save it to the SD card. We're going to build off of a previous example that we've already done, which is where we toggle the camera and we simply get a thumbnail image back, but we don't persist it. That's fairly straightforward. Now, if we want to save to a file, there are a couple of other considerations that we have. First of all, we have to grant the right permission. We're asking the user permission to write to the SD card. Then we want to generate a unique file name so that we're saving a unique image every time and not overwriting the same file. Now, we need to create a file provider in the Android manifest, which gives us temporary permissions to do things like write to the SD card. And then we need to specify which file paths we're giving this temporary permission to. So let's get started. We know we're going to need to specify our permission in the Android manifest, so this is a great place to start. We'll say use this permission, Android name, and write external storage. That's a fairly common one, so you see that it came up fairly quickly. Now we also need to define our file provider in this file. That's going to go after the activity tag, but before the close application tag. So if you see where I am, close activity, close application, right between those two, let's give ourselves some space and say provider. Remember, the provider gives us temporary access to do things like write to storage, which is what we want to do here. So we'll start with the provider open close tag, and in the open part we will set a few attributes. First of all, let's just give it a unique name. We'll say androidx.core.content.fileProvider, and you see it does tend to be in package.class syntax. Android authorities, and we'll say com.myplantdiary.android.fileProvider. This is just a unique identifier for this file provider. So you see in this case what I used is the package name for My Plant Diary and then a little bit of additional information, but essentially just a unique identifier. Android exported means, is this available to applications outside of ours? We don't need it to be, so we'll go ahead and set that to false. And then finally, Android grant URI permissions. We're going to set that to true, and that will give us temporary permission to this URI. And by the way, part of the reason we're creating this URI is it's going to give us a URI that starts with content : / instead of file : / The difference there is a file you can give permission, but that permission applies to all applications that use it. Where a content URI, you can be more specific with temporary permissions like this. One more thing we need to do here is we need to add a metadata section, which is where we're going to identify yet another file. This other file is going to be an XML file that tells us which directories on the SD card we have permission to write to. So let's say metadata, and we'll say Android name, and we'll say Android.support.file provider paths. And then we'll say Android resource, and we'll say @XML/file_paths. So we're referring to a file we've not yet created in the resources XML directory, so this is going to show up as red until we create that file. So creating that file is fairly straightforward. Again, we simply go to res, and we need to look for the XML directory. You notice there is not an XML directory, but no problem, we can make one. We just right-click and say XML. Now, this is a bit of typing, so I'm going to do a little copy and paste job here, but nonetheless, I'll put this up on GitHub so that you can clone it as well. First of all, let's say new file, and we'll call it file_paths.xml. Now, why do we call it file_paths.xml? We'll take a look at what our Android manifest is looking for. It's looking for a file called file_paths in the XML directory. And the extension .xml is just assumed over here. We don't need to put that on the manifest, but we do need to put it on the file name itself. Go ahead and add it to Git. Once it opens, I'm just pasting in something that I have in a scratch pad. What we're saying is these are different paths where we are granting the user permission to write. Pay special attention to this one right here, because when we're in the emulator, that's where it's going to write our images. And that's where we're going to verify that our program is indeed working as planned. So just a little footnote on that. That one, you see it's my debug images, but we also have a couple of other options. My images for when we're running in production, very similar to what we see down here, just without the emulated part that we see in the Android emulator. And then also root images. Save that, go back to Android Manifest, and you see once we save that file, we no longer get a red line on Android resource. Everything marries up just fine. Okay, that's the bulk of the work that we're going to need to do that is outside of our fragment or activity if you're doing this in an activity. Most of the other work that we'll do now will be in this fragment. And because of that, I'll pop it into distraction-free mode. But before I do anything in there, let's just take a quick status check of where we are. We've added the right external storage permission. We've created the file provider in the Android manifest. And we've created file paths in the XML resources folder. The next thing that we want to work on is generating a unique file name. Think to yourself for a moment, how would you generate a file name that is always going to be unique? One common approach is to use a timestamp, so let's go with that. First, let's make a new private function. We'll say private fun create image file, and then we'll have this return a file object, and open close curly just like so. Go ahead and import Java IO file. Okay, let's say val timestamp :string equals simple date format, and then in quotes, 4 lowercase y's, 2 uppercase m's, lowercase d's, 2 of those, underscore, uppercase h, lowercase s, close double quote, and while it's nagging me here, we'll go ahead and import simple date format just like so. And then we're going to say .format and then date. Okay, and we'll need to import java.util.date. There we go. So let's break this down. What's going on here? Well, we start by calling the constructor for simple date format. We eliminate the word new because we know in Kotlin we don't need that like we used to in Java. Just pretend the word new is there if you're used to the Java syntax. Now, when we create this constructor, we pass a string in, and that string has formatting information for how we want to format our date. 4 Y's is the year, and then uppercase M is month, where lowercase m is minute, so be careful on that one. Lowercase d is day, and then underscore hour, minutes, seconds. So we're going to get a string that represents time in this format, which is something that a human can understand pretty well. Now, we have to provide it a date to format into that string, because it could be any date, right? Well, if we take a look over here, what we're saying is we're passing in a new date object. Once again, if you're used to Java syntax, you'd typically have the word new behind that. We don't need to do that in Kotlin. This is just calling a constructor. When you construct a date object, it initializes to the time at which it was constructed, or instantiated, if you will. So we're taking that time in milliseconds, passing it through the simple date formatter, getting a date out in this form. That'll take us a long way. Another thing that we need to do then is we need to get access to the directory where we can write pictures. And so for this I'm going to say context, and I'm going to assert it's not null with a double exclamation, get external files dir, and then we'll pass in environment.directory pictures. So this is just a way that we can go to the Android operating system and say, give me back a handle to the external directory where I can store some photos. We will need to save that into a variable. So let's say val and then storage dir :file ? Which means it's of type file, but it is a nullable type. And then we put our assignment operator so that when we get this directory where we can write pictures, we store it to this variable called storage dir. Okay, now let's go ahead and create a temporary file, make sure we're all good. So we'll say file.create temp file, double quote, plant diary. So we're treating this as a string, but then I can say $curly timestamp, just like so, and it's going to refer to the timestamp variable that I've made up here. So you see we're starting each image with the word plant diary and then a timestamp. And that timestamp is what gives us uniqueness. Next, let's give it the file extension. We'll say .jpeg because we'll save these as JPEGs. And then let's give it the directory where we want to store it, which is what we came up with on line 110. So storage dir, just like so. That all falls into place. Now, let's use one of the scoped functions. We're going to use apply. Let's remember what apply does. We can apply the apply function to an object, and when we do, that object is treated as a this within the block that follows apply. Also, when that block is finished, it's going to return that object again, which means we can chain function calls together on it. Now, we're not necessarily going to do a whole lot with the apply here, but what we want to do is we want to take this file that's created and we want to give it scope outside of our createImageFile function here so that it can be accessed later. Now, remember the variable that's passed in. It's the context object, which in our case is the file that's created here by createTempFile. Now, we want that to be available to our class outside of this method. I'm going to access an attribute on the file class, and that attribute is absolute path. And that just returns the absolute path for this file. You see, in traditional Java days, we'd call get absolute path. Here in Kotlin, we just refer to the property like so in kind of shortcut form. Let's assign this to a variable we've not yet created. We'll call that one current photo path. And that's going to redline because we haven't declared it yet. So let's go up towards the top and let's say private latenit, which means declare it here, but the initialization comes later. Private latenit var current photo path, and then we'll give it a type of string. That's really all we need to do at the moment. Because we've set this construction up here, we're taking this temporary file path, we're assigning it to the current photo path, which is an attribute of our class, so it is available anywhere within this class once this has been populated. But additionally, you see that this function also returns a file. So what we can do is we can add a return statement here as well. And after we invoke file and create temp file, and it goes through all of this work, it's going to return that created file. Okay, deep breath. We're getting a lot closer to where we need to be, but there is a bit more work to do. I'm going to go up to the take photo. Now, the way the camera works is funny. The camera works by toggling this thing called an intent, and in this case we're using an implicit intent, where we're not saying what class should actually do this work. We are just saying that we want to take a photo. So if we want to actually save the photo, we have to modify this call, and we have to pass a file name and a full file path, essentially, or a URI, to the camera and say, oh, by the way, will you save your photo here? So let's see what we're starting with. We have the function takePhoto. We know this is already clicked when the user clicks on the photo button and gives us the appropriate permission. If we see here, we have a couple of alsos chained together. So we have intent media store also. What that means is, on this intent object, we want to do the stuff here that follows. And an intent is kind of like a light switch. It makes something happen. It's just that we have a lot of light switches and we have to decide which one we want to turn on. In this case, the light switch we're turning on is the take picture intent, which says we want to take a photo. And we tell it that by this action image capture. So now we know that this also is one of the Kotlin scope functions, which operates kind of like an extension function and also kind of like a lambda. So when we think of a lambda or a one parameter lambda, think about this intent object which we're creating here, we're instantiating it here. It gets stored into this variable called takePictureIntent. So this is our implicit parameter. And then on the right side of the arrow, we can use that implicit intent. So that's what we have so far. I'm going to clean up just a few things that we don't need so we can have a clean canvas here, just like so. Now we can see, okay, the takePictureIntent contains this intent object, but what does resolveActivity do? It ensures that there is something that can receive this intent. In other words, when we flip the light switch, it confirms that there is a light somewhere that can turn on. With an implicit intent, we're not saying how to do something, we're just saying what we want to do. So this is a proactive measure to verify that we can indeed do that. So let's put a little test in place here and then say if takePictureIntent equal null. That means there's no one who can handle this. So maybe we want to do a toast, make text, and then we'll say context and unable to save photo, and then toast.length long .show, just like so. Okay, and then we'll say else, if we're here, we have a valid intent. Okay, now what we can do is we can get our photo. So let's call create image file, and we are going to assign this to a variable. Let's call it photo file equals create image file, and if we want to be specific, we can say it's of type file, just like so. And then what we can say is photo file question mark dot also. So another this is another one of our Kotlin scope functions. A little tricky here because we have an also within an also, but that's why I explicitly named this parameter take picture intent, because that way we won't confuse two IT variables. You see, as soon as I type also here, it gives me the IT and it says, oh, okay, well, you're operating on a file, so the context object that you'll be receiving is a file object, and for your convenience, I have put it into the variable IT. So variable IT refers to this, variable take picture intent refers to this up here. Okay, so with our photo file, what we can do is say file provider dot get URI for file, and then we need to provide a few things to it. So we can say context, and then we can say our authority. Okay, now what's our authority? Well, let's go back to our friendly Android manifest and remember what we set up a little while ago. Remember this thing, this little unique identifier string that we have here? Well, that's our authority. So I'm going to copy that, and then I'm going to go back to my main fragment, and we can simply paste that next inside of double quotes, just like so. Next, we put our file. And this is where we have to think of our Kotlin scope functions. Our file is photo file. Inside of this scope function, or this lambda, if you will, it's referred to it with the IT variable. So we can simply say IT. Next, well, gosh, let's see. It doesn't like my context here. Why doesn't it like it? Okay, it looks like something going on there just based on the nesting where I am. So I'm going to change this to, I'm going to make a call out to activity, and then we will null assert that, and then we'll say application context directly from activity. I think it's going to prefer that a little bit more because when I said context, it didn't know where to find it, and I've just pinned it to the activity, and I've said, hey, use that context. Once I've done that, you see no more red lines on this line. So now we just have a few more things we need to do. Well, notice that we're calling a function getURI for file, and if you read that closely, getURI indicates it's going to be returning a URI. So let's go ahead and save that into val photo URI, because I have a hunch we're going to need that in just a moment. Now, on the next line, let's go back to our take picture intent, the intent that we're creating up here, and we're referring to with this take picture intent variable. And now let's say take picture intent. And we're going to be a little more specific about which light switch we're flipping on now. We're not just saying that we want to toggle the camera, but by saying .putExtra and then giving it a name, media store .extra output, and then giving it this photo URI. Just by doing that, we're sending a signal to the camera to say, photo file. Oh, would you save the photo to this location? That's a change in behavior that occurs just by adding this extra. Finally, what we can do is we can say start activity for result. And that means let's fire this off to the camera and we'll hear back from it. We have to tell it which light switch we're going to turn on, and that's the take picture intent light switch. The one, of course, we created up here. We gave it the action image capture to toggle the camera. We gave it the extra of the extra output to tell it where to save the image. And then we simply need one of our fingerprints, so we'll say save image request code, just like so. Alt enter. Let's create property save image request code, and we'll set this one equal to 1999, yet another good year. That compiles. Scroll back down, and we confirm that this no longer redlines. It compiles now as well. Now let's go to the on activity result. I could probably get rid of this if test here because I no longer am saving the image as a thumbnail, but let's go ahead and say else if request code equal image save image request code, just like so. The funny thing is, there's nothing we need to do in the onActivity result. It is going to get called, and we could maybe do a toast here and say toast.makeText, tell the user that it's saved. But we don't have to. As a matter of fact, some users find constant notifications to be a bit annoying, so we might even take that one out. One other change I do want to point out. At this point, we're code complete, but one other change I wanted to point out, I had paused the video for a moment, and I realized when I did a copy and paste that I had a different project's package name in here, and therefore a different project's directory. I've not yet committed and pushed this to GitHub, so if you didn't notice that, and you go out to GitHub by the time I commit and push, you'll be none the wiser because I fixed this before the push. But I did want to point out that I did a small little change there. With that, let's go ahead and take it into the debugger. So the emulator's up now, and I want to show a little before and after. If you take a look at View, here's something that's really handy. Tool Windows, and then Device File Explorer. It used to be a lot harder to get here in old versions of Eclipse or Android Studio, but now it's pretty easy to find. Now let's take a look at our debug path. We have storage, emulated 0, Android data, UC, edu, UC, Jones BR, MyPlant diary, files, pictures. I've already opened it to this directory, and I did a couple of tests with the video pause, so you see I have a couple images out there. But this is the full path in this Device File Explorer. Let me hit synchronize, and you count that we right now have 4 images that I've already saved. Let's go back now and toggle the camera, and our success criteria here is that we see a 5th image. So first of all, we go to the take photo function that we created earlier. We'll compress things up so we can see it a little better. And we'll simply step through one line at a time. We create the light switch or the intent. We verify that there is a camera that can handle this intent in this case. Okay, now we're going to create our image file. So we go down, we get our timestamp for the date and time that I'm recording this video. And then we create the file. We save the file to an attribute that can be accessed later. Okay. And now we create this photo file and we pass it through the extra output of our intents put extra function. So in other words, we're creating this path here and we're passing it to our camera and saying, please save the image to this path. If we take a look at the path here, storage, emulated 0, Android data, edu, UC, Jones BR, MyPlant diary, files, picture, and then plant diary with that timestamp that we put on earlier. That probably sounds a little familiar, very similar to the path we have here, also very similar to the path that I showed you earlier that has 4 images, and right now we're trying to add that 5th image. Let's go ahead and choose F9 to allow it to continue. Let's take a look at what our emulator's doing, and we see once we did that, our emulator renders the camera. We click the take photo, we say check, that's going to come down to our onActivity result, and that's going to finish up pretty nicely. Now let's go back to our Device File Explorer. You see for a moment, oh my gosh, there's still only 4 images there. I thought there was going to be a 5th. Well, let's go ahead and do synchronize, and you notice that sure enough, a 5th image now appears. And if you happen to pay attention to the timestamp when I did it, that's roughly the correct timestamp. So in this video, we've successfully saved a file to the SD card. We've used write external storage permission, created a unique file name, created our file provider, and created our file paths. We also used our intent, and we used a couple of flags like a put extra and extra output to tell the intent more specifically what we want to do. Now that we have this image saved, there's a lot we can do with it. We could associate it with a specimen. Maybe we could store it in cloud storage somewhere and then refer to it as needed. So once we have the image saved, it opens up a lot of options to us. I hope this video has been helpful, and I look forward to reading your comments. Thank you.